Good afternoon. Thank you all for attending our lightning talks for master's thesis research. My name is Dr. Danielle Ompad, and I am a professor of epidemiology at New York University School of Global Public Health. I want to offer a very warm welcome to our speakers, Dr. Dahlen, Dr. Hatna, Dr. May, and Dr. Merdjanoff. In this session, each professor will present their research for 10 minutes and conclude with slides on data sets. You can feel free to drop your questions in the chat, and Sydney will be filtering through to pull questions, which will be answered at the end of the session during our dedicated Q&A time. We invite all the students to turn on your cameras to foster an open webinar setting during these talks. We will also be sharing resources on data sets at the conclusion of the session, so please stay tuned. Without further ado, I will offer the floor to our faculty who will introduce themselves and share their areas of practice as well as their research. First, we have Dr. Alex Dahlen, who is in the Department of Biostatistics. Dr. Dahlen.
Thank you. Thank you very much. Okay. Can people see my slides? Yes. Okay.
Yes.
Great. So as an introduction, I'm a clinical associate professor in the biostatistics department, and I run the collaborative statistical core, which is called the BC3. And I'll tell you about what we do with the core in a second. I've also heard that when you're introducing yourself, you should show a picture of yourself doing your favorite hobby. So here I am eating Doritos. Our goals at the BC3 are twofold. The first is to be a high-quality resource for robust, reliable, and reproducible statistical support, which means we work with partners conducting clinical or public health research and act as statisticians in a team science setting. So we'll be the statistical minds in the room, and someone else will bring domain expertise, and together we'll invent a research topic and figure out a method to solve it. And our second goal is to educate and train the next generation of collaborative statisticians, so give our students practical chances to work on real-world projects. This means that my research is not, unlike most other faculty here, I don't have one theme that unites my research. It's sort of projects where I'm bringing statistical expertise and I'm working with other people. So I thought I would take my lightning talk and instead talk through a case study where I worked with a researcher, and you can really see what it was like when statistical expertise came together with domain expertise, pick it apart for some lessons, and then tell you how to get involved with the BC3. So I'm going to talk about this paper I wrote. This is a good example for us because I wrote it while I was at Stanford, so none of these names mean anything to us. But this is a link to the paper, and as a very short introduction, because I only have 10 minutes, the idea is there's a disease called CDH that is a genetic disease that affects newborns, and they're born with a defect where there's a hole in their diaphragm, and it requires a surgical repair. And also, sometimes when newborn babies are doing particularly badly in the NICU, they're put on an extracorporeal life support machine that's called ECLS, also sometimes called ECMO. And when you're strapped up to this life support machine, you can be on it for months. And then the research question that the investigator wanted to tackle, her name was Chrissa Van Meers. She wanted to know, is it safe to put babies on a second round of life support? So they're on life support, they get better, you take them off, and then they start to do worse again. Is it a good idea to put them back on life support, or is that too risky? Her intuition was that many doctors are not doing it because they thought it might be dangerous, but the data was still unknown. So what does the data tell us about the risk? Is a second course of ECLS ever worth it? And they collected data from a study group. We had 10,000 cases of babies born with CDH spread out over a bunch of institutions globally. And here were the average survival rates. So patients who didn't get ECLS had an 86% survival rate. Patients who got one course had 50%, and patients who got two courses had 40%. And this is a statistically significant difference. But of course, it's confounded. The sickest patients are the ones who get more courses on life support. So this isn't a great comparison, and we need to come up with a research question that's sharper, that addresses this confounding. So the first idea we had was, can we match on patients who are equally sick? So find patients who have come off of their first time on life support. They're equally sick, and the doctor is deciding, should I put the patient on a second course or not, and compare those babies. So compare the babies who are equally sick, who happen to get a second course, to the ones who don't. That seems like the perfect comparison. Let me tell you a little bit about the data. We had a lot of health information about the data, but it was only collected about the babies at 2 times. It was collected at birth. We had a bunch of health stats at birth, and we had a bunch of health stats at the time when they were surgically repaired. So when the doctor went in and sewed together the hole in the diaphragm, the doctor would write down how big's the hole, how severe was the CDH. And importantly, no health information collected at the time of the decision to go on life support. So here's a little sketch of why this might be a problem. Like, this is very loosely on the y-axis. I've plot how healthy is the baby. And this is sort of an idea of like how this might happen. So a baby's born, they're doing okay, but not great. They have CDH, they get a surgical repair. And then for some reason, they get a lot worse. They go on life support. The doctors tend to them, they get a lot better. And then they get worse again for a second time. And way over here, this could be months later, we need to decide whether we put them on life support again. So all our health information collected very early on, and the decision is made way out here. So our health information useful, but not a good way to match babies on equal illness. And like another way to say this is no doctor would ever prescribe 2 times on life support. You would never say, I met this baby at birth. What we're going to want to do is put them on life support, have them get better. They'll get worse again, and then we'll put them on life support a second time. Just not a prescription you would make. There's some bad thing is happening, and we have no data that will help us control for it. So this means there's a serious risk of omitted variable bias if you do the analysis like this. So kind of sounds like the research just won't go. Like, this was where we landed early on. But it was a collaboration, so I kept meeting with Krissa, and we kept talking about it. And she said an interesting thing. She said that this idea of putting babies back on life support for a second time was very institution dependent. Some hospitals had adopted this method and would regularly use 2 rounds of life support. Other hospitals had essentially banned it. So instead of trying to compare babies, that opened up the idea of trying to compare institutions. First of all, you can check whether Krissa's intuition is correct. So here, there were 140 institutions that we had data on, and I just computed, and I saw there were 40% of institutions that had literally never, ever put a baby on a second round of life support. And then there's a round of institutions that do it about 5% of the time with some scatter. So Krissa's intuition feels plausible. The next thing I checked was, are there institution types that like to do it? Like, if you see a lot of cases, does that make you more likely to do second ECLS? Or if you use ECLS a lot, does that make you more likely to do it twice? And the answer is no. No association. Feels pretty random. Feels pretty random whether an institution has decided to be the kind of institution that tries this risky procedure and the kind of procedure that is the kind of institution that has banned it. So whole new research program comes out of this. Like, our new idea is to compare institutions instead of comparing babies. We ran a little logistic regression model. We had a GEE because it was clustered. We did some sensitivity analyses because I'm a robust statistician. But like, the idea is this is a new analysis plan we cooked up. And we found this result. We found that institutions that try ECLS sometimes have survival that's 4.6% higher than institutions that have banned it. And it's just as significant. So not the most convincing piece of evidence, but given the chaotic data set, the wrong covariates we had, useful evidence that we could contribute into the debate. Okay, so now let's just mine this example for some lessons about how to approach a problem as a statistician, and what you can think about for your thesis, what it's like being a collaborative statistician. So first of all, I think an important lesson was this was team science. Like, our first idea didn't work. And the way we came up with the new idea is we shared context intensely. Like, we just had a lot of meetings, asked a lot of questions about the dynamics, like How do institutions decide this? How do doctors decide to do this? What is it like in the operating room when you're deciding to go put a baby back on ECLS? It took having trust from meetings, developing a shared language, having a track record of working together. You have to be friendly. Like if I were a crabby dingus, this never would have happened. We needed clear expectation about goals. Like we had to say this is long-term project. We had to work together for a long time. And these skills are not part of the traditional statistical curriculum. Like you don't take a class in how to develop a shared language with a collaborator, be friendly in a meeting. Like these are people skills that are sort of different from statistical skills, but also really important to being a working statistician, important to think about and focus on. And the other lesson is this was an imperfect data set, very clearly, like huge deficiencies in the data we had, but we were able to find a route that felt reasonably robust. So just think creatively about your data. Try to think about ways to stretch it, repose your question. The goal is to wring the highest quality evidence you possibly can out of the available data. Like data is hard to get, it's expensive. You have to run big trials, or like they've been collecting the CDH data for 25 years. So you just try to be as creative and robust as you can to come up with results from it. So I don't know, here are the 4 Rs, here's some strategies. You might want to know, how can you get involved with the BC3 if you want to do this kind of work? The first is that we have a consulting lab that we run where the students are paired on projects and get to practice this themselves. So Evan Wardell will be sending out invites for project presentations soon, and you should sign up if you're interested in trying to work on a project in this capacity. We also offer a course where I teach how to do this and we try it in practice. That's taught in the spring semester. We work with a lot of students. I hire students over the summer and I'm happy to work with students. So send me an email and I'm happy to chat. But I guess in the spirit of your master's thesis, this was to motivate you to try to think creatively, to try to get context about your project, ask fresh new questions, you widen your statistical toolkit. Thank you.
Thank you, Dr. Dahlen. If you have any questions for Dr. Dahlen, go ahead and drop them in the Q&A or the chat. And next we will hear from Dr. Hatna, who is in the Department of Epidemiology. Dr. Hatna.
Hello, everybody. Let me just share my screen. Hello, everybody. My name is Erez Hatna, and I'm a clinical associate professor in the Department of Epidemiology. And you might see me in a few courses. I'm teaching one section of epidemiology and also a course in Introduction to Agent-Based Modeling. And today I'm going just to give you a brief overview of the potential of using modeling, not statistical modeling, but dynamic modelings in your thesis. It's not something which is right for everybody, but we have some good stories, and some students like to do that as a complementary analysis. So in a way, I'm actually helping students in general in thesis, like all professors, but I also sometimes help them specifically in the method that I use. So here I'm going to focus on two methods that we use. One of them is called agent-based modeling. And the second is compartmental modeling. And usually we use these methods for data which have a time dimension. It's similar to time series, which I also do sometime. However, the idea here is to create simulations of the phenomena that you're interested in. Unlike statistical analysis, we try to create find associations. The two methods are similar. Agent-based modeling is more about simulations of the individual interacting. So, for example, if we have infectious disease, then we create a synthetic population of people and try to simulate the transmission of the disease. If you're talking about compartmental modeling, we do something more simpler. We don't really account for every person. We simply count the number of people which are sick and the number of people which are infectious and so on, using equations. But the aims is the same, to recreate the data and then maybe try to understand some issues about interventions or what could have been done or what can be done or forecast if the future in some cases. So agent-based modeling is actually the first method. I'm going to focus on that because this is my main approach. And the idea is that if we know something about the phenomena, why don't we simply try to simulate it? And again, it is best in cases when you have an understanding of the mechanism, for sure. Most cases we don't know what is going on. So we're doing associations. But if we have something more, maybe we can do a model. Here is an illustration of such a situation. Maybe you have some infectious disease and some people are susceptible, some infectious, some recovered. Of course, in reality, you have much more states. And you mix them together, define a few parameters, do simulations of the process, maybe compare it to your incident or prevalence measures, and try to see if you can actually recreate the story. Usually it's very hard, by the way. It's very hard to recreate stuff. But this way you can learn what you don't know. Usually you don't know much. But when you actually learn something, you can say, okay, this is right, this is wrong. And even if its model is good, you can even use it to test the certain hypothesis. This type of method, which is a bit different than the classic epi methods, we are teaching it I'm teaching the course called Introduction to Agent-Based Modeling. So if you're in this course, you can actually learn the method. Here is an example of a model we're doing for an influenza. This is a very simple model. We teach it in our course. And you can see that we have a group of people. Let me see just, maybe I can make a few. In here, we have the population of the people, different balls interacting with one another in a way. In here, we have the number of new cases emerging. And we have all our parameters. You can see we care about how many people are vaccinated, how many people are exposed, how many people died, and so on. And we use this in the course to learn the basics of infectious disease modeling, but also to see if you understand really the mechanism of transmission. Here another example of a more complicated model. This actually model was I worked with the thesis with one of my previous students. And again, this was a model. There was a problem, shigellosis in Brooklyn. We have a nice data set, and we created to our best abilities the historical time series of cases. And after this, we were able to test hypotheses about the intervention. Again, a lot of detail, as you can see. The trick is to see if you know what is going on. You say, okay, where people get infected, maybe in schools, maybe in daycares, maybe at home, what they're doing every day, and if you can put all this information that and if you can estimate enough parameters, which is a big problem, maybe you can actually say something about what happened. And of course, the idea here was, okay, to check different intervention and see what could work, what could not work. You can say, why do we do this? Because we can't test interventions in reality. Not all of them, It's very hard. You can't do experiments on real outbreaks. So we do it on the simulation and try to learn. And next time when we're going to have an outbreak, we can use a better approach. So this is more or less the idea. And here's is another example of data from Taiwan about COVID-19. And this is actually a thesis from my previous student, Betty Yang. And she actually cared about Taiwan. Was a very, very interesting story. They didn't have access to the vaccine very early, but people were very, very respected very much the recommendation of the government. And we had a very interesting waves of COVID-19. And she used a time series analysis, but also agent-based model. Here's an example to recreate part of the outbreak, and then we can learn to see for example, how did vaccination rate really help the outbreak. And here we have a small example. It's all very brief. I'm sorry, I know. of epidemic model, which is based on equations. The idea here is that instead of doing all these agents, which require a lot of programming and a lot of time to run the model, we simplify the model, make a few assumptions, sometimes big one, and then we can simply write equations to represent the same thing. And usually you can write a flow between states, like some people are susceptible, become infectious, they recover, and you need different parameters. So this is also a good approach, and I also teach this approach in my course. And here you can test different scenarios. What could happen if scenario A happens, B happens. Usually you may distinguish between scenarios using parameters like we do here. So what can we do in a thesis? The truth is, this is something that very few students do. Every year I have only 1 or 2 students who actually work on these issues. So it's good if you have temporal data, cases, mortality, and also it can be also some other thing like tobacco use. Anything which has some temporal data is useful in this case. Usually I like students to do a complete statistical analysis and then complement it with a model. This way, especially if you're an EPI student, this way you do the basics, the important part, the core of EPI, and do it additional. So when you do it, you're doing more. But it's good to do the rest. This way you're doing the core EPI and using a new method. Usually it's a good idea for the student to bring you their own question and data. We have our own data sets. However, usually data sets on cases of COVID-19, for example, are quite common. So there is a way to find that set yourself and define your own questions. I have all my own projects, but usually I already have people working on them. Now, it's very good to take the course if you're interested because you learn the method and can connect it with what you already know from biostatistics and what you already know from epidemiology. And also, it's good to be a decent programmer. It means that to know how to use R very well if you're using equations, or to use NetLogo or some other programming language. So it's good for people which are a bit technical, and it could be good for EPI students who have a very clear question, or for the biostat students who are very technical and would like to do maybe a method-based thesis. So send me an email if you are interested. Good idea to take a course, and we can talk and see what is possible. Okay? So thank you very much.
Thank you, Dr. Hatna. Next, we will have Dr. May, who is also in the Department of Biostatistics. Dr. May.
Can you see my slide? Okay. Hello, everybody, and thank you for attending these sessions. And so I'm the new faculty and in biostatistics, and but certainly I'm not new to the field, and so maybe I feel that it will be useful for me to briefly introduce myself, my academic pathway, and so that you can know better about myself. And so I got a bachelor degree in math from the Peking University in 1996, and then did a coding and be a programmer and in a bank, and for a couple of years. Back then is a really well-paid job. And then I come back doing a PhD and in math at Caltech, and in the 2003, but I feel that my training was too mathematics at Caltech, so I did a postdoc in biostatistics at the Fred Hutchinson Cancer Research Center in Seattle for 2 years. And then I have been at a faculty at Georgia Tech for about 18 years, and running from the assistant and to associate to full professor. In the last 6 or 7 or 8 years at Georgia Tech, and I started to be more active and go back my kind of a biostatistics and in the postdoc experience. Because as you know, for some students you do not know, sometimes the tenure and the tenure pressure is real in the in the Georgia Tech or in the or NYU in the other universities. So so after I get a tenure, I started doing more collaborative research, and in particular, I also be the coordinator of the master statistics program at the Georgia Tech, and in the last 6 or 7 years, and also be the co-director for the biostatistics, epidemiology, and research design, the board of the Georgia CTSA, and in the last 6 years. And but I feel that my interest in biostatistics kind of stronger, and I feel that biostatistics will be the focus of the next phase of my research, and so that's the reason I decided to join the NYU and this summer. So my overall research interest is on the statistics, biostatistics, machine learning, and data science, and then applications in engineering and biomedical science and public health, as you can see from the diverse of my training and all background. And from the, I know for some students, they are maybe interested in doing the PhD. For those students, I can also mention my personal methodology research and in the sequential analysis and the change point detections, streaming data or active learning and reinforced learning and so on. And for my collaborative research, that one is more broader. And so I think the Professor Dahlen and I already had to get great, excellent presentations how to do in the collaborative research and biostatistics, and in particular, and for myself, and so I did more kind of research related group sequential design in the clinical trial, or the precision of personalized medicine, and hotspot detections for the infection disease, and the real event monitoring, and so on. And the common theme of my methodology research and particular applications that are published at the methodology papers is how to use the few samples to make a quick and but sound statistical decisions. So here I try to change the style of the talk from the previous two ones. I try to show you and what do you mean by use as a few samples, and what do you mean by use the quick decisions? So here, this is a classical data set in the change point literature. And suppose for those master students, suppose you are working for monitor the annual volume of the river. And if the annual volume of river, if it's going up, you need to tell the government, maybe say, oh, there's the annual volume of the river going up, then in that case, you may need to build a dam, right? And on the other hand, if the annual river going down, then you may say, oh, you need to save the water and so on, okay. So suppose you are working for the government, if you make the right decisions and set the right alarms, and you get a promotion and a monitor prize. But if you get it wrong, I'm sorry, you'll get fired from your positions and so on. And so I normally work on that. If it's in person, say in the classroom, maybe we can show the hand so you can raise the alarm. And to save the slide, I try to show the slide every kind of 5 years, but in reality, should be observed the data one at a time. So now you can imagine, ask yourself, is there any alarm, the kind of annual volume of the river change or not? And this kind of problem happen a lot in real applications, say finance and the stock market going down, or personal, or the COVID pandemic and the hotspot area, infection disease, and the cases going up or not, and also personalized blood pressure, dramatic change or not, and so on. And this kind of problem, so let's see, given this data, you will see whether there's a change or not. And probably is very difficult to see here. And then you say, will be change or not? And yes, in the past, some students say, oh, it seems there's a change here. But if you continue to look at it, the annual volume will drop down and so on. And so if you work on this kind of problems, and in the field, they say if you have fully 100 years of data, then you can easily make the decisions. But the problem is that, and if you can say, oh, 80 years ago, something happened, that's normally, it's not that informative. Just like say in the, say 5 years ago, there's a COVID pandemic. People say, so what? At that moment, how do you make the pandemic decisions? And that kind of a problem has a lot of other applications in the literature. Quantity, the most widely used in the manufacturing engineering and quality control, and also public health surveillance and or epidemiology, and also personalized medicine. So these days in the ICU, there are so many sensors to monitor the patients and signal processing and so on. And again, the common theme is to use the few samples to make quick decisions. So my personal collaborative research in the last 6 or 7 years, and I feel that for the biostatisticians and definitely the number one rule, if you want to do in this collaborative research, you need to be able to using those fundamental knowledge in the sample size or power calculations. That's the basic one, and normally a lot of researchers need help on that one. So once you're beyond this basic sample size linear regressions and those courses, I also work on some using the machine learning method and causal inference, and monitor the HIV hotspot detections and the symptoms screening and so on. So this is my last slide, and for the interest of the time, and for those students, if you want to challenge yourself and to more like say, can I do some like I have a want to do a PhD in the future, and you want to do more methodology research in other cases, and you can work. I have several projects. Some of them may be suitable for the master level students. For example, group sequential design subject to the maximum sample size constraint, or some quick detections for the category data, or the longitudinal data, or rare event data. And if you are interested in some machine learning, and recently I also work on some implicit regularization and say, for example, kind of change point detections or transfer learning and so on. And for those students who want to do more collaborative research and just analyze the data, I expect most students, and for the master levels, it's okay, just analyze certain data. And they have the CDCs and the infection disease and go to the wonder.cdc.government. A lot of my PhD or past master students and go to this website and get the data. And for me, and we work on the HIV or gonorrhea data and in our past research. And also FBS annual crime rate data is a kind of, if you are interested in doing the spatial temporal data analysis and the mimic data of the synthesis, and currently I'm also working on those FDA's kind of quarterly data for the post-market safety surveillance and so on. And for those students who also take my regression courses, and I was doing a project, very likely I will tell you, oh, try to go to some open government data set and to analyze the kind of data. And given the time constraints, and I will stop here, and please feel free to send me email, and if you want to talk more. Thank you.
Thank you, Dr. May. Next, I'm going to turn it over to Dr. Merdjanoff, who is associate professor now, or assistant professor? No.
Oh, that's so kind, Dr. Ompad. No, assistant.
Oh, assistant professor in the Social and Behavioral Sciences Department.
Thank you. Okay, let me share my slides here. Okay. Great. So we're going to talk about some uplifting things today in my talk, mainly climate change and disasters. So just to give you a little bit of background on myself and the training that I have, As Dr. Ompad mentioned, I'm an assistant professor in the Social and Behavioral Sciences Department. I'm also the director for the Environmental Health Program in the Global and Environmental Health Department. My work, because I'm a sociologist, I tend to focus on the impact that social determinants of health have on certain populations and thinking about how the health of populations is impacted by exposure to climate change and disasters. And my work focuses a lot on issues related to housing, aging in the life course, and also mental health, and thinking about how particular populations experience the risk related to these events, how they recover from them, what makes some people resilient to these events and others not. The work that I do is mostly primary data collection. So we're talking about both qualitative and quantitative data sets, some of them longitudinal, which I'm happy to talk about in a bit more detail if there's any interest. And I think a lot of the work that's happening in and around climate change and public health, it needs to be interdisciplinary. And I've been fortunate enough to work with atmospheric scientists and environmental epidemiologists and a whole host of really diverse backgrounds to try to think about ways to improve health when it comes to the climate crisis. So working at the National Center for Atmospheric Research and also being a fellow at the Gulf Research Program. I run a lab here called the Climate Justice and Health Lab. And just to situate climate justice in public health and thinking about, why is this important for us to study? The climate crisis, you may have heard it been described as the greatest threat to global public health. It has a disproportionate impact on socially vulnerable populations, whether it's children, older adults, racial and ethnic minorities, lower income communities, disabled people. They're all experience exacerbating health disparities related to climate change. And so the challenge for us is to start to learn how to best mitigate the health impacts of climate change while simultaneously promoting health equity and social justice. So the mission of our lab here is to work together on research projects, which I'll talk about a couple that we have going on at the moment, to think about the long-term health impacts of acute disasters, whether it's hurricanes like Hurricane Katrina, Hurricane Sandy, Hurricane Ian, the California wildfires, and also think about how these communities who are continuously exposed to events like this grapple with risk perception and decision-making for slower onset climate disasters like sea level rise and coastal erosion. So our goal is really to bring together the qualitative and quantitative methods so that we have a more holistic approach to understanding the true health impacts of being exposed to climate change and disasters. So I'm going to talk about very briefly, just to introduce these studies, 3 different projects that we have going on. They're in various stages. So the first is the area study. This is data that's already been collected, and we have a couple of different papers moving currently to analyze the data, but it's a novel cross-sectional data set of 1,500 older adults, so 55 and older. We did a 20-minute phone survey, mostly over the phone, a bit online, and covered a wide range of survey themes, recent disaster exposure, individual disaster resilience, objective measures of healthy aging. We have quite a few of those, place attachment, perceptions of climate change, and willingness to engage in various climate mitigation and adaptation strategies. And just to give you kind of, actually, Dr. Dahlen, these look very familiar to you, I'm sure, because he did them for us. But you may think, I think there's a misconception that older adults are not concerned about the climate crisis. But when we ask them, is climate change happening? An overwhelming majority say that it is. A smaller majority, but still a majority of older adults believe that climate change is caused by human activities. And they also believe that climate change is going to harm future generations, either a great deal or a moderate amount. And this is important because it's been demonstrated in prior research that ways to get older adults involved in the climate crisis is to kind of tug at their heartstrings and have them realize that they're leaving behind maybe a situation that is not going to be great for future generations. In terms of climate mitigation strategies, 64% of older adults would make some or a lot of changes to combat climate change. 56% of older adults thought that the federal government should invest in renewable energy rather than fossil fuels. And 44% somewhat or strongly believe that the federal government should start planning for large-scale climate migration, so moving communities away from high-risk coastal areas. And about 42% thought that a growing economy is more important than addressing climate change. So, you know, I think we tend to believe, or maybe there's a misconception that older adults aren't that invested in the climate crisis, but what we believe is that they're underrepresented in the climate change movement. There's a willingness of them to engage more deeply with climate change activism and policies. And in terms of health outcomes, there's been prior work demonstrating that engaging in climate change activism can actually have a positive impact on healthy aging. So there's additional reasons why older adults should get involved. Just to quickly move through this, we also have a qualitative study on Hurricane Ian, which is a storm that hit Southwest Florida in 2022. We conducted interviews over the phone and over the telephone. We have about 73 respondents. You can see generally where they were living at the time of the storm. And we have started analyzing the transcripts of the interviews. You can imagine it's going to take us a little bit of time. But we're already seeing themes related to the importance of adult children, how local organizations can help facilitate recovery, how much these older adults are attached to their communities and their homes, and also how there's a pretty high level of mistrust of local government and state and federal government, which makes, you know, trying to figure out ways to put in recovery programming a little bit challenging. Just some takeaways so far. We've found that older adults, they want to live independently. They want to age in their existing homes, even if they're aware that they're at risk for climate disasters. Homeowners insurance is really emerging as a significant barrier that could impact the ability of older adults to age in risky environmental areas like coastal Florida. And we're also noticing the importance of informal social support. And it's becoming increasingly important whenever a disaster hits a state that actually has small to no post-disaster recovery programming, or minimal enthusiasm for climate mitigation policies like what's happening right now in Florida. Just to wrap up, you know, I currently have a grant from NIH that is a K01. It's a training grant, and as a sociologist, we do a great job of telling people what all of the problems are, and then we want somebody else to fix them. But I really wanted to learn how to do that. And so I am getting some training in intervention research and working with CADIO and learning about optimization interventions. And we're currently, actually, you may have seen flyers around on the third floor. We are recruiting for focus groups to try to talk to both older adults and also younger adults about different intervention components that we're going to be including in what we're calling BRACE, building resilience among the aging and climate challenged environments. And the goal is to develop an intergenerational intervention that will have resilience dyads that match older and younger adults to complete different resilience building activities, likely using Zoom or some other virtual platform. So yeah, these are the types of projects that we're working on in my lab, and I'm happy to answer any other questions, and I think I'm at time.
Great. Thank you so much. If any of the students have any questions, please feel free to either raise your hand and ask it, or turn on your microphone and ask it. And while we are waiting for students to ask their questions, I'll pose some questions to the speakers. My first question is, many of you have served as an advisor for master students in this program. Can you talk about some of the challenges and successes you've seen with your thesis students, and kind of what are the things that you wish they knew or were prepared for when they come to see you in January?
Maybe I can say something.
Of course,
Hello,
please.
hello everybody. They're mostly success, of course. We're doing well. Well, when you're doing your thesis, the first thing, of course, is to find some kind of data set, and make sure that you have access to the data set. Make sure that your sample size is adequate. But in many cases, you think you have the data, you think you know where to download the data set, but in the end, you can't. You think that you care about, let's say, a certain population, subset population. Maybe you care about, say, certain ethnic group. But unfortunately, you find out that it's too small. The cell size are too small. So make sure that you know. Also, you might think that your question can be answered using the datasets. However, then you discover that the question given to the respondents were not exactly what you want. So it's a good idea if you have a question and you have a certain data to use, please do it early, download, look at it, look at previous publication. Make sure that what you like to do is feasible. It doesn't mean that you have to show any result. You can actually reject the null. You might fail to reject the null. It's okay, you know? You might actually find that the hypothesis does not hold water. It's fine. But make sure it can be done, okay? And come early. Try to meet your advisor early, you know, meet them. Sometimes I can meet people every 2 weeks or something, every week, even every week, just to make sure they're on track. If you have questions, ask them. Also, if you have some issue with writing, you know, maybe like my case, I'm not an English speaker. I'm a second speaker of English. So make sure you write well. Try to get help in writing. It's a pity that somebody lose points or lose grades just for a good thesis, disorganized, or a thesis which could have that a second reader could have improved the writings. So these are small things that I noticed in the past. And of course, me and other advisors, we're going to help you do it well. But just make sure that, you know, come early. For example, if we see writings early, then we can tell you, oh, please read it again. Please use a friend. Maybe use Grammarly. I don't know what. Just to make sure you have a good thesis. So this is my half cent of advice.
Would anybody else like to chime in?
I would just say, oh, sorry.
No, go ahead.
You know, the spring semester moves so quickly, and it may seem like there's all this time to, you know, explore and you should, but I really use the fall semester to do that, and also consider how long it can take to clean your data set to get it to a point where you're ready to analyze it. I think that students often underestimate how long that takes, and that can really kind of back you up in the spring and lead to some headaches.
Yeah, I was actually unmuting to say almost the exact same thing. I think the way research works is figuring out a sharp research question, a data set that'll work. That's a huge amount of time. Cleaning the data set and getting it ready is a huge amount of time. Doing the analysis happens really fast once you have a sharp question, and then writing it up is a large amount of time. So I think just like make sure you're plugging away regularly at it is helpful. And Yeah, and then a second thing is staying flexible in your ideas. Like often it can be tough. You have an idea, but you can't find the right data set. But you could think of, can I ask a different question about this data set? Can I join a different data set on and make things richer? So I think staying flexible is good advice too. I realized there was one other thing I had wanted to say that I just didn't get to, which is unconnected to my presentation, is we've been building a relationship with the New York City open data team. So they work at the City Hall, and they post a rich set of data sets about New York City, like traffic violations, rat sightings, tree cutting, pollution, bike messenger data. There's just like a huge amount of different interesting facts about New York City. I'll drop a link to where you can see their data sets. I think it's going to be a really interesting resource for uh, like theses that ask questions about the city we're in. There's going to be someone from City Hall data team coming to give a presentation. I think in October. I've been trying to schedule it, but that's like on the radar. We'll make sure Danny knows and advertises it. Or sorry, Dr. Ompad. And then we schedule an event in the spring where students who've done interesting research that makes use of open access New York City data can present at their like data fest that they throw for a week over spring break. So if the idea of doing research on the city you live in is interesting, this is a great resource and something to think about.
Thank you. Dr. May, you wanted to add something?
Yeah, I also just all are the fantastic suggestions. I almost want to say the same things. And here I just added the two more points here based on my past experience working with the master students. And the first one is that, and whatever data set or thesis topic you choose it, and it will be great. You have an interest, and you just like you like what you are doing, and otherwise you will find it suffer is a pain and to do it. So interest is the most important. The second one is that, and keep in mind, this is your thesis and your project, and not your advisor or faculties and so on. And so in that cases, you need to think about it, and after you get it, it's your product, and try to treat it and write in a way have high quality that you are self-satisfied and you are proud yourself, and to present it either for the graduate school admissions, and this is your topics, or when you're doing the job interview, people say what you have done, you can proudly present your project to them. And if you think about that way, and hopefully with less pain to say, oh, I need to do an extra workload and write a thesis, and that's it.
One thing I will add, and I think all the faculty will agree, is that you are not graded on whether or not you have a significant finding. Not getting a significant p-value might be a little disappointing or unsatisfying, but that does not determine your grade. And what faculty are really looking for is that you've gone through the process of developing a research question, designing an analysis, whether that's quantitative or qualitative, to answer that question, and that you have effectively written it up and communicated your findings. So do not get bent out of shape or discouraged and think that you're not going to do well with your thesis if you don't have a significant p-value. And I will also say that not finding a significant association is a finding in and of itself. Sometimes that can be difficult to get published because we do know that there is a little bit of bias in what gets published. However, it is a finding, and it can be an important finding. So please don't be discouraged. I'm just going to open it up for any questions from our students. I don't see anything in the chat or in the Q&A. Okay, well, I'm going to thank everybody for participating. We want to especially thank our faculty members for taking the time out of their day to do these presentations. Their insights and expertise are always invaluable to guiding our students on their thesis journeys. And to our students, we're really appreciative of your engagement and your dedication as you prepare to take the next steps in your research. Your curiosity and commitment are what is going to make events like this and your thesis so meaningful. We are definitely excited to continue supporting you through future sessions, and you're going to hear from other faculty moving forward. So keep an eye out for the QR codes to RSVP for the next sessions, and we'll be providing links to data sets that will be vital resources for you. After today's session, you will receive the slides so you can revisit and cross-reference the information that has been shared. And then we also invite you to complete a brief survey, which will be sent via email. That feedback is going to help us improve these sessions and tailor them to your needs. And as an epidemiologist, which is what I am, but also as students of public health, you should understand the value of response rates. So we would appreciate 100% response rate on your feedback. And then I want to thank you once again for being a part of this community. We look forward to seeing you at our future events. I would encourage you not just to go to one of these, and encourage you and your classmates to go to several of these. And if you can't come, then watch the videos, because this is going to help you think about your thesis proposal this semester. Thank you very much and have a great day. Thank you, faculty.